3.3 Graph using intercepts. X-intercept. The x-intercept of a graph is the x-coordinate of a point where the graph crosses the x-axis. So if the x-intercept of the graph is a, then the graph crosses the x-axis at the coordinate a, 0. The y-intercept of a graph is the y-coordinate of a point where the graph crosses the y-axis. If the y-intercept of a graph is b, then the graph crosses the y-axis at the point 0, b. So if I give you an equation of the line 2x plus y equal to 6, then the x-intercept will be 3, 0. When y is 0, x is 3. And vice versa, the y-intercept will be 0, 6. If x is 0, y is 6. Part A. Find the x-intercept and the y-intercept of the graph of the equation. So here, I'm going to make a t-chart. When x is 0, y is 7. When y is 0, x is -5. Therefore, 0, 7, and -5, 0 are my x and y intercepts. Okay, I'm going to show a little bit more work for this next one. So when x is 0, y equals -1/4. So this is our y-intercept. But when y is 0, x will be -2. So this would be our x-intercept. And for this equation, I'm going to try to make it look more friendly by multiplying by 10. Okay, so again, I'll set this up. When x is 0, y is 3. When y is 0, x is -2. Y-intercept, x-intercept. Okay, let's look at one more. When x is 0 and when y is 0. So this is obvious. So y is 6. And when y is 0, we're going to have to do a little bit more work. -18/5. y-intercept, x-intercept. And this next one is relatively straightforward. Part B, draw the line that has the given intercepts. X-intercept of 10 is given by the point 10, 0. Y-intercept of -1. Okay, so we have a point here and a point here. You can go ahead and connect the dots, or the points. So here we have x-intercept equal to -7, which is about, we could just place it right here. And then y-intercept 4. And draw the line. Okay, let's see another variation of problems involving x and y intercepts. Graph the equation by finding the x and y intercept. Label the points where the line crosses the axes. Okay, so I'm just going to use a t-chart to represent my x and y intercepts. When x is 0, y is 8. When y is 0, x is -4. Go ahead and plot my intercepts. So 0, 8. Okay, it says to label the points. And -4 goes here. And now, here we have x, y. X is 0. Y is -2. And when y is 0, x is 2/5, which is about 0.04. Okay, so 0, -2, and let me label that. 2/5, 0, it's about here. I'm going to label that. There we go. And now identify the intercepts when you're given a graph. So the x-intercept will be 2, 0, and the y-intercept will be 0, -1. For this one, x-intercept will be, if this is 1, -1, 2, 3, -4. Excuse me. Then the y-intercept, 1, 2. Let's take a look at a word problem. A submersible designed to explore the ocean floor is at an elevation of -13,000 feet, which means 13,000 feet below sea level. So basically this is a submarine. The submersible ascends, meaning it goes up to the surface at an average rate of 650 feet per minute. So I'm anticipating that this is a distance problem. The elevation, another way to represent distance, it's just this is from measuring from bottom to top of the submersible, is given by the function E equal to 650 T minus 13,000, where T is the time in minutes since the submersible began to ascend. So basically this submarine is going upwards. Part A. Find the intercepts of the graph of the function and state what the intercepts represent. So for the t-intercept, that's when e equal to 0. So t would equal to 13,000 over 650. And then after you simplify this, it will equal to 20. And it will be 20, 0. This represents the time it takes the submersible to reach 0 feet, which is the sea level. And for the e-intercept, I have to let t equal to 0. So that's e will equal to negative 13,000. So here's my intercept. This would represent the elevation after 0 minutes. Meaning the time the submersible begins to ascend. Okay, part B, graph the function and identify its domain and range. Okay, so I'm going to draw my x and y axis. I'm going to label the x-axis t for seconds. This will be the sea level. And then y-axis will be e in feet. And then I'm going to do a cutoff here and just estimate negative 13,000 around this area. And 20, 0 to be around this part of the graph. And I'm going to go ahead and graph. Okay, this submarine needs to stop here at sea level, because if it continues to go up, it wouldn't make sense. It will be in the air. A submersible can't fly. And the point needs to end here for the y-intercept, because there's no such thing as negative time. So, yeah. And our domain will be from 0 seconds inclusive to 20. And our range will be negative 13,000 inclusive e less than or equal to e less than or equal to 0. And that concludes our lesson.